In WindCity, we do passive variable geometry turbines, which are turbines that self-adapt to the variable nature of fluids, wind and water. We have a patent, and we have this provisional name, vStream, for variable stream. So the need analysis starts from the wind and the city relation. There is a circular chance here. So the answer to the question, are we harvesting all the energy that nature is offering to our cities, is no. And there is a particular wind blowing below conventional wind turbines, which is the urban boundary layer that is nowadays wasted. So distributed wind energy generation is a circular chance for the cities, where lives 60% of our planet in cities. So we have a solution for urban environments, and the fact is that the cities could harvest energy from wind and water, but the variable flows found in the urban environment today reduce efficiency by more than 60%. And the pain point is the technological gap between the conventional offshore and onshore applications, where regular flow allows high production, and instead the potential built environment applications that offers a variable flow, where the conventional machine continues to switch on and off with a low level of production, as in the right of the diagram. So variable flows introduce two great challenges, and we have a yaw challenge in the horizontal axis turbines, because frequent changes in wind direction force the machines to keep yawing without setting up for production. And instead, on the right, we have a pitch challenge on the vertical axis wind turbine, which are ideal for variable fluids because they are omnidirectional, but they have this problem with the pitch. A fixed pitch machine is a non-self-starting machine. So as we can see in this graph, in this diagram, the no pitch machine is not able to self-start, and the maximum pitch machine is able to self-start, but it does not produce in an optimal state, in a regime state. So if we just could have both the no pitch and the max pitch, and so we did this solution to realize to have the same technical features in the same machine. The solution is always adapting to change, and we have these 3 degrees of freedom that arise spontaneously during the free movement on any blade in the air or the water: pitch, diameter, and rotation. And our solution, it interacts with the variable forces of nature and self-regulates this pitch, diameter, and rotation to maximize energy production. So, and there is no external forces, no actuators to do this. It's only equilibrium with the forces of nature, getting out the maximum energy from the fluids. And our experience towards the reliability stems from the strategic installations that we have in Garda Lake in northern Italy. And we are there since late 2018, and we will go from the lakeshore to the building with this European project recognition, where we will be able to install the turbines even in the rooftops. And if you consider wind and water, we ask ourselves why the two fluids together. We could take advantage of a technology transfer, yes. The creators here in these pictures tells us how much there is in common between the world of air and the world of water, because of this Reynolds number similitude that is made self-evident. So we did aquatic environment tests, we are doing it, and the same passive variable geometry concept, the same patent, with a turbine of similar dimension, can generate up to 10 times more energy going from wind to water. So we're developing this technology for blue growth, and we have these tests running out by 2020 in the French laboratory. We have impact as an energy production result. We are able to have a levelized cost of energy, which is in line with the most mature renewable techs, with a payback time from 3 to 6 years. So we are there as an impact with energy production result. But we also have impact for climate change goals. We have impact with land consumption. We can consume even 70 times less than a solar photovoltaic panel if we go to water. And also we have result in terms of energy return on energy invested. We can perform 2 times better, 3 times better than standard variable fluid turbines. And our business-to-business model includes R&D contracts, open innovation, and small modules for going in farms project, because we are able to customize size rotors. And of course, as we adapt to the nature, we want to adapt to the user with system configuration. And the next slide is all about this system configuration. You can compose your turbine from our ecosystem of adaptation products. So we can adapt to the class of wind in the left with the rotor. Then we can adapt to what you want to have as a connectivity, just a web app or IoT gateway. We adapt as for the support you want to direct support to the ground, want an under support for the rooftop, we can do that. And also we can adapt for the security, so the safety. We have a shutdown and protection, which is standard, or we can also have the brake that functions in off-grid and in lockdown, as we are experiencing now. And also we can deliver energy to the battery or to the grid with two different converters. And of course, we have barriers to competition. We have three kind of patents. The last one is also for multi-fluid. And the market opportunity is very high, because we can stay in the market just with a scenario where we take just 0.6 to 1.5% of the market. And this is our market entry roadmap. We started with our first prototype 3 to 4 years ago, and now after power converter system integration and patent industrialization kit, we are in the pilot installations period, where we have the first early adopters, which hopefully are multi-utility groups and very big players in the country for the energy sector. And so we are looking for seed corporate period. And our team is facing an important pivot point to accelerate the transition to the market. We have multiplied the research and development strategy, and we switch it. We have not only technological R&D, but also market R&D now, because we need to have two opposing but integrated souls to create dynamics that bring us forward. And of course, we wouldn't be nobody with, or we wouldn't be anything without the Partnership for the Goals, which is also the last but not least Sustainable Development Goal from the United Nations. So we thank all our partners and early adopters and the awards that we had so far. And please, you can contact us. We will be more than happy to share with you our goals. Thank you.